Were there some right here in the hall, clerk?
No, Molly, I haven't no.
We're revisiting this Triplett Model 850 vacuum tube voltmeter. I bought this last year, and just because I wanted something with a really big analog scale. And this has about as big an analog scale as you can get. But when I got it, I could tell when I tried to calibrate it that it wasn't working correctly. It works mostly. It'll measure some, it'll measure resistance, it'll measure voltage, but when you're measuring AC in particular, it drifts a lot. So this needs to be recapped. But first I'll demonstrate what's going on with it by running through the we'll zero the meter and then show you what it's like to try to AC balance the meter. It just won't. It just won't. So I have a voltage source over here. I have the meter here. I've already removed the screws from the cabinet so we can get this out. But we'll start by zeroing it out. And you start that by zeroing mechanically the meter right here. Get my wee screwdriver. And that's just a mechanical, pardon me, a mechanical adjustment you make to get this exactly on zero, which is, from my perspective, is exactly on zero. And then you turn it on and you set it to DC volts positive. Light comes on. You should let it warm up. If you haven't seen the prior video, the two tubes that are in here, one was a, what were they? Can't recall anymore, a 6AL5 and a 12AU7, and those have been both replaced by solid state equivalents sometime in the past. I don't think they came out of the factory that way, but that was a pretty common thing. They're replaced by solid state FETs, fit into the same tube socket, and they're pretty stable. They don't need a warm-up period like these guys do, or like tubes do rather. So to do a zero adjustment, you change this to DC, you ground it to itself, and then there's this zero knob right here that lets you zero that in the same way you did the mechanical zero. And again, to my eye, that's right where it should be. So that's done. Oh, then you switch this to minus volt DC volts, and that shouldn't move. That's the theory. And in fact, it does. It goes up a little bit. And I don't know if you can see that. Let me turn this to about here. If it's on plus DC volts, it's zeroed. If you go to minus DC volts, it goes up a little bit. So it's out of balance. That's one of the things we have to look at. But we'll make note of that and move on to the next test, which is the AC balance adjustment. And this is the one that really can't be done. It can be close, but it can't be done. Turn the switch to AC volts, which is there. Place the probe. This probe has both a DC and AC position. Place that on AC. It's DC and AC ohms. And then you crack the case open a bit. I can do that because, as I said, I've got them uninstalled already. The screws uninstalled. And there are a series of 1, 2, 3, 4, 5, 6 adjustments right across here. And the one we're after is the one that's right next to the neon light right there. That's the AC balance adjustment. Or AC zero control rather. And we should be able to turn this to zero the meter again. And I can't. That's probably not real obvious. I've got the adjustment at full clockwise. If I go counterclockwise, the needle drops. Full clockwise, it's below zero. It's reading a negative, and I can't adjust it up to a negative. So that's one of the things. There is some component in here that's out of tolerance. This should stay the same if I switch from AC to DC, and it doesn't. There it's below zero. On DC negative it's above zero, and on DC positive it's at zero. So there's something wrong here clearly. Can't be adjusted to where it needs to be calibrated. So what are the likely suspects? Well, the likely suspects are always the same suspects, aren't they? This meter, like all meters, is just chock-a-block full of really precision resistors. However, here and there floating around are some electrolytic capacitors. There's one right there, C2. There are other capacitors. There's one, I think, if I recall correctly, just one ceramic disc. So there's a ceramic disc. It's probably just fine. There's an electrolytic C2, and the C3 through C7 are tubular, standard non-polarized, or C3, through C7 are standard capacitors. And I've ordered those replacements already in this parts baggie. And the one other thing that's kind of worrisome is the wrong word, but there's an ancient solid state diode right here. They call it X1 as a rectifier. And you can't get those anymore. Nobody makes those. And what I read someplace on some electronics forum that you might get away with replacing that with a Schottky diode. So I have a Schottky diode in hand. And we'll see. What I'll do is I'll replace all the capacitors first, see if I can make the adjustments I need, see if it looks like it's drifting back and forth. And if that fixes it, I'll leave the diode alone. In fact, I can show you the diode. It's kind of a funny looking thing. I have never seen one before like this. It puzzled me for a bit as to what it was. Here it is right here. CP20 International Rectifier Corporation. It's a giant among diodes. I don't recall even being able to find specs on how it was supposed to work. But that's the next thing. I've got 1, 2, 3, 4 capacitors to replace up here. I think the big electrolytic is here. While I'm in here, there are a lot of high precision carbon resistors, as I said. I will check those to make sure they're all within tolerance. There's the solid state devices that replace the tubes right there. And yeah, it's a TR1119 and a TR1002. Replace those two tubes. So I will replace the capacitors. I will check some of the resistors, particularly on the top end up here, because that's where all this stuff is. And we'll check back in when that's done. All right, I've replaced the capacitors. And there was a telltale right down in here. See if I can get this on camera for you. Come here, light. It's right here where the electrolytic was, is a tar-like substance there, and a smear over here as well. And if you look at the electrolytic, which is this guy, it's really sticky, and you can see, I can see, and you probably maybe can see, right around the rim of this plastic sleeve is that tarry black substance. So this electrolytic had failed. Apparently it's leaking material. So replaced all of them, and now it calibrates wonderfully. Everything works well. I ended up not replacing the old CP20 rectifier in there. I didn't see a need to because it's working satisfactorily now. What we'll do real quick is run through these caps and see how they test the ones that came out in the first place. We'll just run through them real quickly for giggles and see how they look on the ESR meter. And I'll try to bring you over here so you can see the ESR meter with me. Okay, again, a reminder, this is my cheapy ESR meter. Cost $14 or something, and provide your own case and battery. But you know, it gives an indicator. It certainly doesn't stress anything you put in it by any means. But we'll take a look at this electrolytic, and if I can grab the parts list here. It says it's 13.17 microfarad, 2.5 ohms ESR value, which isn't too bad. Loss of 2.5%, so it's a bit leaky. Yeah, this should be a 10 microfarad 13, so it's run up as they do once in a while. So anyway, we have physical evidence that it's leaking its bodily fluids and needed to be replaced anyway. This big guy was a 0.1 microfarad, but it's 1,000 volts, which is why it's so big. I keep threatening to replace these cheap probes and keep not doing it. Okay, we'll see if we get 100 nanofarads or something. Yeah, very close. 100 nanofarads, not very lossy. So that's, 0.1% loss is not bad. So there's that one. Then these red guys are 0.05s at 400 volts. Tiny chiefs. 72.26 nanofarad. So it's creeping up. It's supposed to be 50 nanofarad at 72.6. Crept up. This one's supposed to be the same. (77) 2% loss, voltage loss. And finally, this guy, which is a 0.01 at 400 volts. And it's 0.018, and it has a 6.1% V-loss. So they aren't terrible, but in any precision application, most of them have drifted too far to be useful, and one of them was leaky. So it was a good exercise to replace them. I'll button the meter back up and put it on the shelf, and I now have a working Triplett 850. See you next time. Take care. Be safe.